How are you guys doing today? Today we are going to lecture about functions that have negative exponents that turn into complex fractions that later involve the factoring formulas. Okay, we have a function here of x to the negative second power plus x divided by x minus x to the negative second. So in the numerator, x to the negative second turns into 1 divided by x squared plus x divided by x minus 1 divided by x squared. So now the object is to put or input parentheses around binomials because you see two terms in the numerator and two terms in the denominator. So you want to incorporate parentheses around these binomials and then put a baby division sign for the long division sign in the middle that separates them. And then put them side by side. Now we have 1 divided by x squared plus x in parentheses with the small division sign divided by x minus 1 divided by x squared. So now we need to make x a fraction. So we want to put it over 1. So now the function is going to read 1 divided by x squared plus x divided by 1 in parentheses divided by x divided by 1 minus 1 divided by x squared. So now we need to get a common denominator within both parentheses. So in the first parenthesis on the left, we have to multiply the second term by x squared over x squared to obtain 1 divided by x squared plus x over 1 times x squared divided by x squared, close parentheses with a small division sign in the middle, and then you have to multiply by x squared divided by x squared for the first term on the right hand side in parentheses minus 1 divided by x squared. Now this will break down to 1 plus x cubed divided by x squared in parentheses divided by x to the third power minus 1 divided by x squared. Now you want to multiply by the reciprocal and you get x to the third plus 1 divided by x squared, which, and you notice how I rotated the function in the numerator because multiplication, addition, subtraction sometimes are commutative with addition. So here we see a 1 plus x to the third power is equivalent to x to the third power plus 1 divided by x squared times, and you flip the second set of terms in the parentheses on the right and multiply by x squared divided by x to the cube minus 1. As you see, the x squareds cancel out. So now we're left with two binomials, x to the third plus 1 divided by x to the third minus 1. Both of these factor. So on the right hand side, we want to deal with cubic factoring formulas. So the addition formula for cubics is dealing with a cubed plus b cubed, which is equal to a plus b times a squared minus ba plus b squared, and a cubed minus b cubed is equal to a minus b times a squared plus ba plus b squared. So let's look at the first function, x cubed plus 1. You want to take the cube root of x cubed and you get a is equal to x. Then you take the cube root of 1, you get b is equal to 1, and you plug into the addition formula x plus 1 multiplied by x squared minus 1 times x plus 1 squared. Now we want to deal with x cubed minus 1. So you take the cube root of x cubed again and get a is equal to x. Then you want to take the cube root of 1, you get b is equal to 1. So we will obtain x minus 1 times x squared plus 1x plus 1 squared once we plug it into the difference of cubes formula. So we put this together, and x to the third power plus 1 is equal to x plus 1 times x squared minus 1x plus 1 divided by x cubed minus 1, which is equal to x minus 1 times x squared plus 1x plus 1. At this point, nothing cancels out, so either solution is correct in x to the third power plus 1 divided by x to the third power minus 1, or x plus 1 times x squared minus 1x plus 1 divided by x minus 1 times x squared plus 1x plus 1. Now, you see how we're dealing with complex fractions, factoring formulas, and laws of negative exponents. That is why knowing your formulas are extremely pertinent to your success within mathematics at different levels. If you need math tutoring, please text me at 559-744-3169 for services. Please donate to my Cash App with the $sign up front, MLBFan. That is again with the $sign up front, MLBFAN. Thank you so much for your time and efforts. Please reach out, refer someone. Let's learn math together. Thank you.